Question number 6. An umbrella is made by stitching 10 triangular pieces of cloth, 2 different colors. So if we assume that an umbrella of 10 triangular pieces. So I will not be drawing many triangular pieces. I'll just draw. So of 2 different colors. 2 different colors, each measuring 20 by 50 by 50. How much cloth of each color is required for the umbrella? So if we just assume the umbrella to be like of 10 different colors, so that makes 1 2 3 4 5 6 7 8. I'll just write here 9 10. So if the umbrella is of different colors, so maybe let's say blue, and green. So in that case, like what happens is we will have 5 blue shades and 5 green shades, each of the same dimensions, which I have taken out here. Maybe one example for blue, one example for green, but it's given that the pieces of cloth are actually same, each measuring 20 by 50 by 50 centimeter. So how much cloth of each color is required? Now each color 5 pieces, so cloth for each color will be 5 times of each of these colors, 1 2 3 4 5. So what we will do is we'll find out the area for one triangular portion of any color, okay, because all these pieces are same. So for one triangular piece, what happens is the sides are 20 centimeter by 50 centimeter by 50 centimeter. So let's find out the area for this. 3 by 2, 60 centimeters. So area of one triangular piece, S I will just write directly now 60, since we have already done so many exercises. So 60 centimeter minus 20, 60 centimeter minus 50, 60 centimeter minus 50 centimeter. So that will be 60 centimeter, 40 centimeter, 10 centimeter, 10 centimeter. So immediately I can just take this out. 10 centimeter into, let's say 6 into 4 into 2 more zeros, now 1 and 2 centimeters square. So 10 into another 10 into 6 will be 2 into 3, 4 will be 2 into 2. So that will be one of the 2, we can take out 2 into 100 into root over of 6. So that will be 200 root 6 centimeter square. So this is for one piece. That means cloth required for blue color 5 pieces, isn't it? 200 root 5 root 6, so it will be 1000 root 6 centimeter square. Similarly, also cloth required for green color, same, 1000 root 6 centimeter square. So of course we can assume, like I did not write here, like, but let the 2 colors be blue and green. Okay, you can use other colors also, okay, all right, because it's saying 2 different colors, that's why I've just used accordingly. All right, moving on to question number 7. A kite in the shape of a square with a diagonal 32 centimeter and an isosceles triangle of base 8 centimeter and sides 6 centimeter each is to be made of 3 different shades. How much paper of each shade has been used for it? So it says that we have a square kite. Square means all the dimensions are going to be same, and the diagonal, any one of the diagonals, okay, diagonal is given. This is as per the diagram. Diagonal is given, and then of course we have an isosceles triangle. So let's say this is shade 1, shade 2 and shade 3. For the isosceles it is given 8 centimeter, 6 centimeter, 6 centimeter. For the square, of course, no dimension is given, but diagonal is given, because diagonal also will be same for square, no? This side, or either in a square diagonals are same, okay, so both of them will be same, 32 centimeter. So now what we are going to do is find out the area required for each shade. That is for red, shade 1, shade 2 and shade 3. Now shade 1 and 2 will be same, no? Because a diagonal cuts the diagonal of a square, actually what happens, divides it into 2 triangular parts, so no problem. So we find out for one, we'll find out for the other. And shade 3, of course, we'll use Heron's formula. Now the question is, we don't have the sides to find out the area of a square, but we can use this diagonal that is given to us. Okay, let us solve. How can we do this? Let the side of, okay, let's forget about this. Now given diagonal of square, that is given to be 32, diagonal of the square is given to be 32 centimeter, but we know that diagonal of square is, the formula for diagonal of square is root 2 into side. That's how we find out the diagonal of a square, isn't it? Diagonal of a square is root 2 into side. So that means root 2 of side will be equal to 32 centimeters. So using this, we can easily find out the side of the square, 32 by root 2 centimeters. So okay, we'll just leave it as it is. Okay, so that means side of each square is 32 by root 2 centimeters square. So in that case, now we can find out area of square will be what? Side square. So side 32 by root 2 whole square. So this will be 32 into 32. Root 2 square will be 2 isn't it? 2 centimeters square, right? Because root 2 into root 2 we have learned in the chapter of polynomials, that will be 2. So 216, so 32 into 16 centimeters square. Now 32 into 16 will be 512 centimeters square. So this is the total area of the square. Okay, so what we will do now is shade 1, shade 2, isn't it? So what happens is diagonal divides the square into 2 equal triangular parts. So that means area of shade 1 will be equal to area of shade 2, isn't it? So that will be what? This is the total area now. So total area of the square. So the total to shade 1 shade 2 same hobo, that means that it will be half hobo, so that will be 512 divided by 2, so that will be 256 centimeter square. No problem with that. Now for shade 3, we have the sides. The sides are 6 centimeter, 6 centimeter, and 8 centimeter. Shade 3 means this portion. So that one we can just find out using the Heron's formula only. So let's find out the semi-perimeter. 6 plus 6 plus 8, so 12 plus 8, 20. That will be 10 centimeter. So area of shade 3, 10 minus 6, 10 minus 6, 10 minus 8. So that will be 10 into 4 into 4 into 2 centimeter square. So we can just take out 4. This one we can easily take out of the square root. 10 is 2 into 5 into 2 centimeter square. Another 2 we can take out. Root 5 centimeter square. So that will be 8 root of 5 centimeter square. So I'll just do it here, the rough part. So square root of 5. So 2, 4. 1 decimal, so 2 zeros, plus 2, 4. So 4, how many times? 2 times, let's say 2. So 2 2s are 4, 2 4s are 8, so 16. Another 0, 44. So 2.2, one more time, let's say 3 times. So 3 3s are 9, 3 4s are 12, 1 left, 3 4s are 12, plus 1 13. So I believe 2 decimals should be enough. 8 into 2.23 centimeter square. So it will be 2.23 into 8. 8 3s are 24, 2 left, 8 2s are 16, 20, 2 left, 8 2s are 16, 17, 18. So that will be approximately 18.04 centimeter square. Of course, as per the textbook, if you go for one more decimal, let's try to go for one more decimal if you want the textbook solution, something like that. So 2.23. So that will be another 9 10 2. This will be 9 left, 7 3 4 5 2 0 0. So 4 4 6. So I think that will be 6 times. So 6 6 are 36, 3 left, 6 6 are 36, 39, 3 left, 6 4 are 24, 27, 2 left, 6 4 are 24, 25, 26. So 8 into 2.236. So let's multiply. 2.236, 8 8 6 are 24, 2 left, 8 3s are, sorry, 8, my bad. So 2.236 into 8 8 6 are 48, 4 left, 8 3s are 24, 25 26 28, 2 left, 8 is 16, 17, 1 left, 8 is 16 plus 1 17. So that will be 17.888 centimeter square, approximately 17.9 centimeter square. So this is how you can do this particular problem. So make sure that you practice at home and do your best. Thank you.